Okay, now I will jump into an explanation for developers that would like to see how the code is organized. Okay, I will do my best to explain this because I have already coded this like a few weeks ago, so it's not fresh in my memory. But let's go to the code. The first thing I'm going to do is to stop this node from here so that I can run it directly at Visual Studio. And so what I'm going to do is come here. Here you find network workspace, like Visual Studio workspace. So you double click here and you have, sorry, let's put this here. Let's put it here. Okay, so now you have the network workspace open. Okay, and in order, the way this is organized, you have to look for the network folder here that has a thing called network app. Okay, and you put it like second, because the first one is the network script. Okay, the network script is the node.js quote unquote command. When we type node network, what we are running essentially is this. Okay, that in turn is going to call this network root. Okay, that is going to run like a standard procedure for any application we have, that we are loading the dependencies and the app schemas and the secrets that are needed, and then we run what we call the application. These are like a uh, like a booting process. Okay, this is to enable the command at Node.js. This is uh, like like the booting process, and this is the application per se. Okay, so this is the application. So let me close all this stuff so I can give you a tour of this code. But essentially, if you want to run this, you just position yourself here and you hit F5 and it's going to run, and you can debug anything on this code. Okay, because now it's running inside Visual Studio. Awesome. So once you have this network app, okay, once we have the network app, let me see if I can remember what was going on here. Okay, so things are organized in this way. We have two things, or three things. We have the network, or what we call the setup of the network, that essentially are all the objects and components we need to load in memory to have this network node operational, okay, as a network node. We go into details later, but essentially more or less that's the idea. On top of the network or the node code itself, okay, then we are running network services. Okay, today we have two network services, but tomorrow we'll have 3, 4, 5, 10, or as many network services we want to invent. Okay, so the first two network services are the social graph for the social application, okay, storing all the relationship between social entities, and trading signals, that is the service that allows the distribution of signals, trading signals, over a peer-to-peer network. These are two services. They are optional to be run, and the way you define it is at the UI, as I explained before. You define which one is going to run, depending on if you put or not those nodes into your own peer-to-peer network node. Okay? So what is going to happen here is that if those nodes exist, then it's going to start the network service, each of the network services. Okay. And the third thing that you have inside the node are the interfaces. Okay. In general, we are using in Superalgo the concept of an interface as the gateway through where incoming messages or connections or information is coming into a certain application or module or whatever. Okay, so the context also is needed to well define what we are talking about here. The interfaces of a network node in this case are the network interfaces, okay, meaning the protocol level connectivity. Okay, today we have developed two interfaces because we need them. One is WebSockets, okay, that use WebSockets technology, and the other is HTTP interface. Okay, the reason that we need HTTP is because for posting trading signals into the network, we don't need to have an open connection. Okay, all the time we just need to post the signal, and it can be without being connected. Also, because the connection between the nodes, not at this current version, but in the future, will depend on the amount of token power each node has. So the reason for that is because we have to distribute the signals in a certain order depending on the amount of SA tokens each nodes have as token power. And eventually the clients will connect, I mean the applications, mobile application, the application will connect also depending on the amount of tokens they have. So that is the way we are going to guarantee that the distribution of signal goes in a certain order. And because of that, we need to post the trading signals not at any place of the graph, of the network graph of how nodes are connected between each other, but we have to do it at the start of the graph, okay, at the nodes that they don't have incoming connections to. So where the node, I mean the start of the graph in this case is are the set of nodes that have the highest amount of token power, okay. So every signal goes first to the node that have the highest amount of token power, and from there they start going to the other nodes that they have less and less and less token power, okay. It's not implemented right now, but at least we have the concept, and we already have a HTTP interface that allows entities that don't have that much power to access the nodes that has the top of the token power, okay, because they access via HTTP and not via WebSocket, where it's going to be strictly forbidden to connect if you don't have a lot of token power to node that have a lot of token power, okay. So for that reason we already implemented both interfaces, but what you need to know now is that we have these two, and one third is coming, that is WebRTC, that is on the way, it's under development. So we will have soon three, okay, and user will define which one to turn on based on the UI, okay. So these are the three main sections here, okay. And let's go now into detail of what's going on.